Hello everyone, welcome to the video lecture series of operating system. In today's session, we are continuing with the topic process synchronization. Myself Kunal Panchal, your instructor. In this particular session, we are going to discuss the applications of semaphore. In previous session, we have already understood what is semaphore. It is nothing but an integer variable which can be used for to solve different classical problem of process synchronization. Okay, so that we have already understood in the previous session, and we have discussed one of the application of semaphore in previous session. It was nothing but a critical section problem. So how we can solve the critical section problem with the help of semaphore, that we have already understood in the previous session. In this particular session, we are going to discuss the remaining two application of semaphore. So the first one is order of execution between the processes. Means if you want to execute some specific sequence out of all available processes in main memory, okay, how we can do it with the help of semaphore, so that we are going to discuss in this session. And third application is resource management. Means if we have multiple replica of a particular resource, and if you want to use that multiple replica simultaneously, how we can do it with the help of semaphore. So let us discuss the remaining two application of semaphore. Okay, in this particular session, we are going to discuss the second application of semaphore, in which we need to discuss the order of execution between the processes. Means you can see in this particular scenario, suppose in multi-programming operating system, okay, you know very well there are multiple processes which are ready for execution, and they are located into a main memory, and they are waiting for resources, okay, for execution. So every process, have equal rights. In the case of operating system, every process has its own process ID. Okay, they have equal rights. Okay, or we can say privileges for having resources for execution. Okay, so and how these processes will be scheduled for execution. For that, we have already understood in process management chapter, in which we have discussed various CPU scheduling algorithm, like first come first serve, round robin CPU scheduling algorithm, shortest job first, okay, priority based scheduling algorithm. We have discussed various algorithm. So based on these algorithm, operating system will schedule the process for execution. But what we need to do is, in this case, suppose we have one requirement in which, say for example, for understanding this example, let us discuss if we have three processes, P1, P2 and P3. Okay, so instead of executing P1 first, then P2 and then P3, if I want to execute P2 first, then P1 and then P3, just like these I have shown this to you in this particular slide, in which P1 needs to be executed first, sorry, P2 needs to be executed first, then P1, then P3. If this is my requirement, okay, so what I need to do is, say for example, in real scenario, there is a dependency between processes. Like say for example, why I need to do such type of execution. So for example, suppose if one process, P2 process we have, okay, which is intended for to find out the radius of a particular circle. P1 is intended for, say for example, the area of a particular circle, and the P3 is intended for find out the cost of that particular area. So definitely, first of all I need to find out the radius of a circle, then I need to find out the area, and then I can calculate the cost. Yes, so there is a dependency in this case. So if we have such type of requirement come into the existence, so how we can solve this problem of dependency, okay, among the processes with the help of semaphore, let us discuss. Okay, so what is my order of execution? P2 followed by P1 followed by P3. Okay, so this sequence I need to execute. So you can see in this particular table, if we have three processes, and if you want to execute this particular order with the help of semaphore, so you need to have two semaphore, okay, instead of one. So for three processes you need to have two semaphore. So this S1 and S2 is nothing but two semaphore values, and the initial value of these two semaphore is initialized by 0. Why it is initialized by 0? I am telling you, because in this case we are using semaphores for not resolving the problem of critical section, because we have already discussed in the previous session, if you want to resolve the problem of critical section by using semaphore, the semaphore value would be initialized by 1. Yes, but in this case we are not going to initialize the semaphore values by 1, because we are not talking about critical section problem. In this case we are talking about order of execution. Okay, so the initial value of these two semaphore is 0. Now what will happen? I need to execute P2 first. So what I will do, you can see in the second column, as far as second column is concerned, in first row I have not mentioned anything, and in the second row, in second column, second row, I have directly executed P2. Yes, so means what? I need to execute P2 first. So I need to forcefully execute this sequence of processes, because I need to have the value of P2 and P1 first. Then I can calculate the value of cost. Yes, P3. So what I will do, if I want to avoid the execution of P1 or P3 first by the operating system, what I need to do is I need to execute the wait first, wait statement, or we say wait operation first, as far as P1 and P3 is concerned. So if I want to execute P2, P1 and P3 sequence, but if operating system wants to execute P1 first, so that cannot be executed, because if P1 wants to execute its task, okay, so what it needs to do? So first of all it needs to execute wait. Once wait is successfully executed, then and then P1 can enter into a critical section and execute task. But in this case, but P1, before going to execute P1 needs to execute wait, and wait of S1 is nothing but S1 value, initial value of S1 is 0. So wait cannot be performed. If wait is not performed successfully, definitely P1 cannot start its execution. Same way in the case of P3, again wait needs to be executed first, then P3 can execute task. But in this case, wait on S2, initial value of S2 is 0. Again wait cannot be performed, because what is the intention of wait operation? Wait will simply decrement the value by 1, but in this case S1 and S2 value is already 0, so it cannot be decremented. Yes, so that's why even though operating system wants to execute P1 or P3 first, it cannot be executed. Okay, so P2 would be executed first in this case, and once P2 started its execution, and then if context switching is happened, still P1 or P2 will not have the chance to execute its task. because the value of S1 and S2 is not updated yet. Yes. Okay. So P2, once P2 finish its execution, then it will execute signal of S1. Once, because why signal of S1, why it is not signal on S2? Because after P2 I need to execute P1. So that's why I need to increment the value of S1 by executing this signal operation. So once this operation is executed, now the S1 value would be incremented by 1. Now it is 1. Now this wait of S1 in P1 case can be executed. Yes, now P1 have chance to execute that task. Yes, once P1 finish its execution, okay, then again it will, now the next, which process needs to be executed next? P3. Yes, so if P3 wants to execute, so definitely wait of S2 needs to be executed successfully. Yes, so I need to increment the value of S2 so that wait of S2 can be executed successfully. Yes, so that's why at the end of the P1 execution I have mentioned signal of S2. So now the S2 becomes 1 and now wait of S2 can be executed and then P3 will start its execution and complete its task. So in this way you can explicitly set the order of execution among the process that you want, okay, with the help of semaphore. So I hope this application is clear to you. Now moving forward to the next application of semaphore, which is nothing but resource management. So as far as resource management is concerned, suppose as I told you earlier, suppose if we have, for example, 5 printers, okay, if we have more than one replica of a particular resource, and if we have, say for example, if you want to execute more number of processes concurrently, if you want to achieve real parallelism, so what we can do is, if we have say for example, to understand this concept, how semaphore can be used for resource management, that we are going to discuss with the help of this example. So in this we have one process PI which contains this set of statements like wait on S, critical section, then signal on S, then remaining section. Okay, so if this set of process, this set of statements needs to be executed properly, so definitely we can achieve a resource management with the help of semaphore. So let us discuss how we can do it with how we can use semaphore for resource management. For example, suppose if we have 5 printers with us, and if we have 5 printers, how many processes we can execute concurrently? 5. So if we have 5 resources, definitely we can provide 5 number of processes to it for execution. So S, the value of S is initialized by 5, because how many number of processes that you want to execute, so that value you need to set as a semaphore value, semaphore initial value we can say. Okay, so S is nothing but 5 in this case, and now by having this value S is equal to 5, let us execute this set of code, okay, and check can we execute all these 5 processes in 5 printers successfully to achieve real concurrency. Let us discuss. So S, initial value of S is 5. So wait on S can be performed? Yes, because the wait on S cannot be performed when the value of S is 0. But in this case, value of S is 5. So wait on S can be performed easily. Okay, now once wait on S performed, okay, so now the value of S would be 4 because it is decremented by 1. Now this P1 process, for example, P1 is entered into critical section. Okay, Now, can any other process enter into critical section? Say for example, P2 comes. Okay. Now, what is the value of S? 4. So, can wait on S can be performed? Yes, it is performed because it is greater than 0. Yes. So, again P2 can enter into critical section by executing wait on S. Yes or no? Yes, it is possible. Now, the value becomes 3. Okay. Now, another process came into the existence, and that process wants to enter into critical section to access shared resource. So in this case, again the value of S is 3. So again we can execute this wait operation successfully, and P3 can enter into critical section. In same way, process 4 and process 5 can enter into critical section, and then the value of S becomes 0. Means what? We cannot execute more than 5 processes by having 5 resources concurrently. Okay, so and once you enter the multiple processes, in this case 5 processes we have, which are successfully entered into critical section, they can easily access the shared resources, and whatever the operations they want to perform, they can perform concurrently. Yes. So in this way we can manage the resources. But one thing you to keep in your mind, whatever the number of parallelism, or you say whatever the number of process that you want to execute among the various resources, so that process value, number of process value needs to be set as a initial value of semaphore. These things you to keep in your mind. It is very important. Okay. So in this case, we are not talking about, we are not dealing with critical section problem. In this case, we can allow multiple process can enter into critical section. Yes. So this is all about resource management. In this session, we have discussed 2 applications of semaphore. One is resource management, and second one is order of execution. So I hope it was clear to you. Thanks for watching this video. See you in the next one.